When everything seems to be going against you, remember an aircraft takes off against the wind and not with it. Hello everyone, I am Anirudh and I welcome you all to Aero MIT's Orientation 2021. Here is a short video focused on our team, what we do, our passion and our ambitions. We also explain this year's recruitment process at the end, so make sure you stay tuned. Founded in 2009, Aero MIT is the official aero modeling and drone research team of Manipal Academy of Higher Education. We design and fabricate unmanned aerial vehicles for various research and competitive applications. Apart from this, we also participate in multiple leading competitions across the world. As you can imagine, building a model from scratch is a massive challenge, and hence we follow a team hierarchy that offers a structure and stability. Our team is supervised by a well-wishing faculty advisor to whom our team leader reports our progress. The team is further divided into 5 subsystems with members working in their respective fields. Leading from the front, we have our Aerodynamics subsystem, who start generating the DNA of our build by analyzing the problem statement and initializing the design. The structures and composites subsystem then works on building the aircraft by exploring various materials. The next integral part of our dynamic team is the Advanced Drone Research subsystem, whose members work on making multi-rotor UAVs for various research and competitive applications. The Research and Development subsystem works on gaining knowledge on a plethora of topics and publish research papers. And lastly, we have the Management subsystem, who combine all our resources effectively and efficiently. Our flying sessions are like the icing on a cake. Not only do we get to test out our builds, but the failures teach us oh so much more indeed. Well, we put in a lot of effort carefully oriented towards giving immense benefit to our team and in the process create a learning platform for all. We invite you all to be a part of our family and take with you some valuable experiences. I now hand over to my teammates who will explain in detail about their respective subsystems.
I am Anshul Chitnis from the Aerodynamics subsystem at Aero MIT. Here in Aerodynamics, we focus on decoding the problem statement, arriving at a conclusive design, and further documenting it in a design report. Upon receiving the problem statement, the mission constraints are identified and a thorough examination of the scoring formula is done to obtain the maximum possible score. The design process is kickstarted with a rudimentary design, abiding by all the guidelines of the problem statement. A suitable airfoil is chosen to achieve the predicted score. The aircraft is then modeled using CAD software and is analyzed using various computational tools to optimize the aerodynamic characteristics. The aircraft performance and stability analysis are carried out to obtain the stability characteristics which determines the safety and controllability of the final design. The structural integrity of the aircraft components is computationally analyzed and further validated using the experimental data acquired. This analysis determines the material's capability to withstand the loads and stresses generated during flight. This entire process is then detailed and documented in the form of a technical design report. Apart from competition builds, we also work on experimental projects. This includes studying the stability characteristics and performance of a canard aircraft and designing a vertical takeoff and landing aircraft in collaboration with the ADR subsystem. The knowledge gained and applied by the subsystem members is not only restricted to aerodynamics but also involves flight mechanics, aircraft design, research and optimization techniques. The members will use industry-grade softwares like ANSYS, SolidWorks and MATLAB to visualize and implement the concepts learned in class, hence enhancing the learning process.
Hello again. Today I'll be giving you a brief overview of the various responsibilities and functionings of the Structures and Composites subsystem. Our main aim at Structures and Composites is the realization of the aircraft designed by the Aerodynamics subsystem. We work closely with them to design and build a flight-capable and structurally sound aircraft. We are responsible for everything in the build, selecting the materials, deciding the building processes, making the payload mechanisms, and choosing the appropriate electronics.
Working with us, you will gain knowledge about the various materials used in building an RC aircraft, the building processes we employ, developing and testing payload mechanisms, selecting the appropriate electronics, and everything that is required to bring the aircraft to form. You will also be trained in CAD modeling and will be given a basic idea of FEA. Crash analysis, flight testing, and repairing crashed aircrafts is also our responsibility. Innovation at Aero MIT has always been a staple. Carrying forward this trend, we as structures and composites strive to come up with novel building techniques and incorporate advanced materials in all our builds. As the name suggests, working with composites is a major focus of our study. A composite is a material made from two or more different materials that when combined are stronger than those individual materials themselves. The use of composites allows us to build lighter and better performing aircrafts, and you will be trained on working with various composite systems and dealing with the nuances of each of them. You will gain experience in various manufacturing processes that are required to build a high quality composite component while efficiently incorporating the said component into the structure of the aircraft. So if gaining hands-on experience and materialization of ideas is your forte, then the structures and composites subsystem is your choice. We look forward to working with you and making your student project life a memorable one.
Hey everyone, this is Ishita Agarwal from the ADR subsystem. ADR does an extensive work on UAVs and experimentation, which is a hint of fun and exploration. We focus on designing semi and fully autonomous aerial vehicles, racing drones, as well as research on multiple fixed-wing hybrid VTOL configurations. We work in fields like image processing, object detection, object tracking, SLAM, also known as the simultaneous localization and mapping, path planning and mechanical design, and analysis to implement them in our projects. We implement various cutting-edge technologies like Robot Operating System known as ROS, MATLAB and Simulink, ArduPilot, MapLink, and ANSYS to have a proper understanding for our problem statements by performing simulations and analyzing a model. The fundamental skill sets of our subsystem are the electronics, the AI, and the design. The electronic include fields like avionics, quadcopter dynamics, microcontrollers, control theory, sensor fusion using sensors like LiDAR, radar, and GPS modules. The UAV control is a fundamentally difficult but a very interesting field. Our work revolves around simulating the quadcopter dynamics and integrating onboard computers with the actuators. AI works with ROS, computer vision, machine learning, and deep learning. We build neural network-based models to help UAVs identify an object as a target for any autonomous missions, as well as simultaneously implementing path planning algorithms while using SLAM for mapping the environment. Apart from the electronics and AI, we also work on the design and analysis of our UAVs. ADR is presently working on two of its projects, which is a bicopter and an autonomous hexacopter. We take part in various competitions like drone racing, drone simulation challenges, designing autonomous drones, and many more. We not only have hands-on experience with these technologies, but also provide a platform to explore booming space for research-oriented candidates. Apart from the commitment to the work, we look for people who have passion for innovation and an inner desire to be inquisitive. The overview of the work that we do in ADR is far beyond the scope of this video. Be a part to experience the adventure. We look forward to having you on our team.
To quote a famous scientist, research is to see what everybody else has seen and to think what nobody has thought. The research and development field is one of the most versatile and ever-growing aspect of the aviation industry. At the R&D subsystem in Aero MIT, we attempt to strengthen our knowledge starting right from the fundamentals and working our way up to complex subsystems. Aerodynamics, stability, and electronics are only a few popular areas of research that are undertaken in the subsystem. Every individual who is a part of R&D is equipped with the knowledge of the tools that enables us to carry out extensive research. Each member is proficient with modeling softwares like CATIA. We use these softwares to make 3D models of aircrafts, wings, or aerofoils that we wish to analyze. Additionally, 3D modeling allows a member to appreciate the details of the models. The student will also be introduced to various simulation softwares such as SimScale and XFLR to carry out the analysis for the research projects. The simulation is an excellent way of gaining perspective about the behavior of a body in different conditions. Another major skill that a member learns in the subsystem is technical writing. Technical writing is one of the most important skills of a researcher. Keeping that in mind, we ensure that every member has extensive practice of this skill. Additionally, we dedicate our efforts to ensure that the theory which we learn is constantly reflected in the projects that we carry out. At R&D, we expect our team members to constantly push the boundaries of their areas of interest. Currently, we are working on several papers like improving takeoff performance and an analysis paper to decrease the drag of an aircraft. Each member constantly strives to test their abilities in different areas of interest. In this subsystem, we strive to work with other subsystems in order to provide innovative ideas which can then be implemented in the competitions in which Aero MIT takes part. Being a part of the R&D subsystem, a person regularly experiences setback during the research process. However, what drives us forward is that what we will achieve at the finish line will be worth every effort.
I am Ashrita from the Management Subsystem of Aero MIT. The main function of our subsystem is to coordinate and amplify the efforts of all the subsystems in order to achieve a common goal. The functions of our subsystem include budget and plan for resources. As a first step, we develop an understanding of the role of each subsystem and list out their requirements. Upon completion of this phase, the next step is to plan for these resources, that is, the materials and the finance required. We then identify the sources not only across the country but all over the world to procure these materials. Sponsorships. Keeping in view the activities of Aero MIT, we identify sponsors, engage, negotiate and bring them on board for supporting the activities of Aero MIT. The success lies in the quantum of free or concessional supplies that can be procured. Finance. A critical responsibility of our subsystem, considering limited financial resources available for the entire activity, we manage these available resources diligently. Social media. We create engaging content to promote our student project and keep our social media handles active at all times. Management subsystem prepares you for real-life situations and improves your decision-making ability. At the end of the season, I'm sure each one of you would be able to manage a team working towards a common goal.
As mentioned briefly, our team is constantly on the lookout for enhancing our value addition from small to big. Despite the challenges faced due to the pandemic, the team worked passionately towards achieving the goals set for this season. We quickly adapted to the need and moved to online mode. Our coordinated efforts yielded the desired results. Aero MIT has proven to be one of the most successful student projects in MIT. We also organized Skyrush in our technical fest Tech Tattva. Skyrush was held online this year and teams from all over the country have participated in it. Our flagship competition, SAE Aero Design, is held in the US annually. Some other competitions that we take part in are SAE India Southern Section Aero Design Challenge, IIT Bombay's Tech Fest, VIT Velore's Aero Dominator, and Sahyadri College of Engineering and Management's Aerophilia. We are pleased to share with you that we were the runner-up in the technical presentation in SAE Aero Design Knowledge event held this year. We secured the second position in VIT Velore's Aero Dominator, and we were the second best Indian team in BRICS Future Skills Aerial Robotic competitions. Our team values commitment and passion more than anything else. Please do not hesitate to join us just because you belong to a branch that is directly not associated with the aeronautical branch. We will be conducting online recruitments for the first years very soon. Please fill out the registration form that will be released on 27th of May, following which a written test and interviews will be conducted. Should you have any further clarifications, please do not hesitate to contact us. Looking forward to having you all in the team. Do register to experience this wonderful journey. We wish you all the best.